Hello everyone, welcome to Sorcerer's classes. This is Tushar Shaw, and in this video we will be continuing to solve the UPSC CS Main 2020 paper that we were solving since the last 7 videos or 8 videos, I guess. I don't know. This one would be the 8th video. Okay. So yeah, so this was the paper that we were solving, and in accordance to the rule that I have already told you, that this is not a multiple choice paper, and therefore as the paper being subjective, you have to write the each and every steps properly, so that you can fetch good marks out of it. Okay. So if you miss any of the step, or you may write any step wrong, then you may get your marks deducted. Obviously, we have not solved quite a lot of subjective type questions in normal practices, because most of the competitive exams usually occurs in a multiple choice based. Okay, here the only advantage is, here you won't be getting any negative mark for the questions. Okay, if you are wrong, you will be getting a zero, no negative marking for that. Okay. So let us, without wasting any time, let us look into the questions that are given. So in the last video, we did up till question number 4A. So we will be continuing from question number 4B in this case. Okay. So question number 4B says, explain the phenomena of capillary action using with showing relation between the angle of contact and the nature of liquid, and derive the expression gamma is equal to half H rho G R, with the symbols having the usual meanings. Okay, so this is a kind of big derivation that we need to follow. So sit tight, obviously. Okay, so let me just draw a diagram for you. Okay, and then we'll be continuing to solve. This is kind of a big question. I guess the whole video would be finished by this question only. So let us draw it. My drawing is not up to the scale, so please consider that also. I can draw well in copies, but this is a I am using pen tablet in this case. So these are all water, kind of a sick water, but we'll consider that to be water only. So here we have our capillary action up till this point. So here we give a value theta over here, and for this case also we have theta. Okay. So so yeah, as I was saying, so let me just complete my diagram first. Um, So we will be having one angle over here, one would be over here, and one would be in opposite to this side. Okay, I'm not drawing the theta angle this side, because we may just calculate it by one side only. Okay, so this angle is also theta. Vertically opposite angles these are, vertically vertically opposite angles. Okay, so this side would be t cos theta, and this side would be t sin theta. Okay, now we are considering the above angle, because obviously the rising is taking upwards. Okay, not sidewards, it is going upwards. So we will be considering the action on that direction. Okay, so if we draw the circumference, one cross section, we will be seeing that t cos theta is caused by one part of the T cos theta is the pull of the capillary pull caused by one part of the one point at the circumference, and the total circumference is 2 pi r. Okay, so the total pull exerted by one from this surface of the liquid at the capillary is 2 t cos theta into 2 pi r. Okay, so this would be the, so by statement we will be writing that the total vertical force acting upwards is 2 pi r t cos theta. Okay, so this was one thing, like the equation number 1. Then let me just write the equation. So this is equation number 1. Now the volume inside the capillary is equal to area of cross section into height of the liquid in the column, height of the liquid in column. Okay, so the area of cross section is pi r square and the height is considered to be h. Okay, we just name, let me just give it in a drawing so you'll just understand. Okay, so this is the pointer. Yeah, so this height is h. Okay, so pi r square h. Now converting it into the density term, like if rho is the density, therefore mass of the liquid in capillary would be equal to uh, pi r square h rho. Okay, now weight would be equal to, now we know from basic physics that we know that weight is equal to mass into acceleration due to gravity, which is equal to, so mass we have calculated just pi r square h rho into acceleration due to gravity is g, where the value of g is equal to 9.8 meter per second square. Okay, so this is the case. Now we have to correlate. Okay, the weight is pulling downwards and the capillary action is pulling upwards. Therefore, at some point of the column, the capillary action stops and there is no net downward pull or upward pull. Okay, so in that case, that case is known as the equilibrium point. Okay, so at equilibrium, the total upward force is equal to the total downward force. Okay, so the total upward force we calculated it to be 2 pi r t cos theta, and the total downward force is calculated to be pi r square h rho g. Okay, so here we calculate the value of t is equal to half h r rho g divided by cos theta. Okay, cos theta. So this would be the case, but in this case we consider the value of theta to be equal to 0 degree. Okay, so for theta being 0 degree, t is equal to half h r rho g. Okay, now in this question we are like instead of t they have given gamma. Okay, h r rho g, sorry, this is looking like gamma. So h r rho g, and in the question they have given the t, they have written as gamma. So you can just do the derivation in terms of gamma instead of t, like replace the wherever the position of t there is, replace them with gamma. Okay, so this is the derivation that is required. So this is the exact sorry. Okay, so the symbols have obviously have the usual meanings. Yeah, so this is the exact derivation. Now as we have time, let us move on to the next question. This question number 4c, question 4c is kind of an like idiotic question. Why I am saying this? Because either there is a printing mistake in the solution, most probably there is a printing mistake in the question set that I have been provided with. Okay, because obviously such an easy question is not given in the exam for usually for 10 marks. Okay, the above question that we have done already, this is such a long derivation, it carries 10 marks, and this question also, let me just read out the question for you, it also carries 10 marks, but like it is kind of an unjust way of setting paper. Maybe I'm not blaming them, maybe it is the printing press who did the mistake, but that's okay. So to eliminate the liquid junction potential, KCl salt bridge is used, which is okay. That is why the salt bridge is made up for. Does it eliminate the liquid junction? Yes, it does. If not, how salt bridge eliminates the liquid junction potential? Now, basically, there is a grammatical mistake in this question. Like it asks whether the KCl salt bridge is eliminating the liquid junction potential or not. Yes, it is eliminating, but it says if it does not, then how does the salt bridge eliminate the liquid junction potential? Like The salt bridge is eliminating the liquid junction potential itself. Why is this question mentioning two times? Okay, you understand the difference. So this is the case, but still the explanation for salt bridge is required. So I'll just explain it in two lines. So you may just write it down, and then we'll be ending this video up. Okay. So the E of liquid junction potential energy, the value of liquid junction potential is T minus plus T plus, not plus, sorry, T minus T plus divide by into RT by NF ln A plus minus 2 divided by A plus minus 1, where A is the activity of the species. Okay. So in this case, when a salt bridge is introduced, because of the presence of ions like KCl, the T value, the T minus value is equal to T plus value. Okay. What then happens is, then the liquid junction potential calculus found out to be 0. You may just put the value here. You will be seeing that you minus these terms, you will be getting the value 0, and in this way mathematically we destroy the liquid junction. Okay. Liquid this includes the prevention of formation of liquid junction, elimination of liquid junction. Okay. So this is the exact representation, or the exact way of how this question must be solved. Obviously there is a printing mistake in the question, grammatical mistake you may say, but that is okay. I just explained it to you. Okay. So let us wrap this video up. I guess I'll be completing as we have done in question number 4C. We will be doing from question number 4D in the next video. Okay. So thank you guys for this video. I'll see you guys in the next one.